start the recording. Basically today, if you look at the course schedule, is kind of a catch-up day. So I've kind of set it aside for us to talk about the midterm exam, which is now open, and you have until Sunday at 11:30 p.m. to take it. So I want to share some information about it. Excuse me, and then see if you have any questions related to the content, that's on the midterm, or any questions related to mini project number 2 over confidence intervals. So let me share my screen. I'm not sure if I have shared this document with you all before today, but I'll post it up in the announcements after class today. But your midterm is actually now open. It opened at midnight. And it will remain open through Sunday, which is April the 2nd. It covers the content of the lessons from Module 1 and Module 2. You have only one attempt, but you are able to use the notes that you've taken throughout the course, the PowerPoints, the flow charts, the resources that are available in the course. You will need to access Minitab. So let me make a note about that. You will need access to app.minitab.com. You'll also need a basic calculator to do addition, subtraction, multiplication, division, and I think square root. You are allowed 150 minutes, which is 2.5 hours, to take the midterm exam. I don't believe at the 2.5 hour mark, it will not cut you off. It will simply notify me that you took longer than the allotted 2.5 hours. Okay. But you're allotted 2.5 hours. It's worth 150 points. And it does indicate on the course syllabus that if you don't take the midterm, you'll receive an F if you do not withdraw from the course. So the midterm is a required assignment. It's not optional. You have to take it. As far as the format, it is within D2L. There are true-false questions. There's 5 of them. It covers some of the basic vocabulary and concepts, and it kind of gives you a list of those topics that we've covered to date. There are 5 fill-in-the-blank questions, which are also vocabulary and basic concept related. And again, I kind of give you a list. There is a quantitative data problem where you have to calculate the descriptive statistics, mean, median, mode, range, standard deviation, variance, quartile 1, quartile 3, the interquartile range. So you have all of those that you have to calculate and then match up or indicate what the answer is. You have a binomial distribution with 5 questions. You have a uniform distribution with 5 questions, an exponential distribution with 5 questions, and 2 questions about a confidence interval. I also provide at the end of this document, and again, if I haven't posted it, I'll get it posted when we're finished today, some things that you may want to remember if you didn't make notes about. I give you any kind of formulas you may need. So I remind you how the quartiles and percentiles are related. I give you the formulas for determining the outliers within a data set. I have all of the formulas for the binomial distribution, as well as the table that indicates how to perform the calculations for the binomial. I have the formulas for a uniform distribution. I have the formulas for the exponential distribution as well as how you do the calculations. And then I have the formulas for the confidence intervals and the sample size estimation for both Z, T, and proportion. And I remind you, and this table kind of got scrolled down a little bit. The table that you need for doing the sample size estimation to find your critical value is given at the top of the page in the actual exam, but it's also here on this page. Okay, it's a pretty safe bet if Miss Ralston has listed out all of this stuff, the formulas and things, it is highly likely that you're going to need them. Okay, so even if once I post this, if you just want to print it out so that you have all of that stuff kind of all together on a single page, that works. Okay, any questions in general about the test, about the midterm?
What if there's a question about a cutoff?
That's the normal distribution.
Okay.
Okay, you could, I don't think I have any questions. If you look at this list of things that I have listed here, I did not include any questions on the normal distribution.
Oh, okay. Okay, thank you.
But you do have binomial, uniform, and exponential. I did not include the normal because we spend a great deal of time talking about the normal in Stat 1401 in the first course. So I focused on the new distributions, which were binomial, uniform, and exponential.
Okay, I see.
Other general questions?
Stem and leaf plot. Did we do that one?
Did you do what?
The stem and
Stem
leaf
and leaf
plot.
plot? Yes, we did a stem and leaf plot. I can show it to you in just a minute. Okay. All right, let me see if I can go over here and find us an example. We need some data. So let me stop my share just a minute and find some data because so I can show you the stem and leaf plot. That would have been a lesson early on in module 1, and we just need some data. So let me see if I can find some data.
Okay.
I'm sure I have some here on my computer somewhere. Okay, Nana, I've found an example that we can use to talk about
Okay.
the stem and leaf plot. Okay, with the stem and leaf plot, you have the raw data. And typically with a stem and leaf, it's a way to organize your data. It helps you to order the data. So I'm just going to make some notes here on this particular document. Okay, but stem and leaf is just an organizational tool. It helps us to order the data from typically low to high. It's also good for smaller data sets. This particular data set for the example that I've pulled up here has 50. It tells me in the initial description that there are 50. You know, when I say smaller, smaller is relative. But like if I had 500 data values, I probably would not do a stem and leaf plot. So what happens with a stem and leaf is we basically separate our data value by their place values. Your stem, in this case, we have a 2-digit number, such as, say, 57. So you have the tens digit, which is the leftmost digit, and you have the ones digit, which is the rightmost digit. For a stem and leaf, the stem is the leftmost digit, and they're normally listed vertically going down the column. So I have, in this case, the lowest value in my data set was 46, and the highest is 98. So I have values in the 40s, the 50s, the 60s, the 70s, the 80s, and the 90s. So I've listed the stem 4, 5, 6, 7, 8, 9, and the stem is the tens digit of each one of the numbers. In a stem and leaf, the leaves are the rightmost digit. Whoops. Got a spelling error there. And with the leaves are listed horizontally in numeric order. Now, the data that I have here is provided in order. Okay, it's already ordered from low to high if you inspect it. So I notice for the 40s, I have the numbers 46, 48, 49. So I would write, let me change colors. Okay, here's my 4. So I would write 6. That's the number 46. Then I would write 8, 48. And then I would write 9, 49. Then I do the 50s. I have 53. So I have 5 and then a 3 for 53. Let's see, 60s. I have a 2, a 4, and a 4, and an 8. Notice if it repeats, like you have 62, 64, 64, 68. You do repeat the value if it repeats, because that indicates that there are 2 64s in the original data. Then we have our 70s, 5, 7, 7, 8, 75, 77, 77, 78. Then you get to the 80s, and I got a bunch of them, so it may take me a minute. Got 2, 1, 2, 3, 4. Okay, so I got a 82, 84, and then 85 occurs 4 times. So I'm going to write 5 4 times. Then I got to go back and look again. Then I got 286 and 87. Okay, so 286, 87, 288, and 289. Then I noticed I had a 90. Let's see if I got another one. Then I have 1, 2, 3, 4 91s. 2 92s. 1, 2, 3, 4, 5, 6 93s. Then we have 1, 2, 3 94s. A 95. 2 96s. Okay, so basically I've broken it apart. Now, had my data not already been in numerical order, I can now see that the lowest value in the data set was 46. The highest value would be 98. I can also identify, so things I can identify here. We now can find the minimum, which is the lowest value. I can tell you that it's 46. I can tell you the maximum, which is the highest value in the list, if I didn't already know it. I can find the mode, which is the one that occurred the most, and it happened to be 93 because it occurred 6 times. We could also find the median, which is the value in the middle, because we know we had 50 values. So I need to find, let's see, the 25th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Here's the 25th value and the 26th value. So my middle is between 89 and 90. Well, halfway between 89 and 90 is 89.5. So the middle would be 89.5. It's just a way to organize the data. Again, it works best for small data sets. It allows me to order it. And then you could also think about the skewness if you wanted to, because if you picture bars around each row, you have a horizontal bar graph, and you could see that most of your data is grouped on the higher end. And when most of the data is grouped on the higher end, your distribution is skewed left. Now, I don't believe you have to actually create one on the test, but there are some true false or fill in the blank questions related to a stem and leaf. Let me see if I can scan the true false questions here. Okay, I don't see one there. And I don't see one here. I know in the past there has been, there's a true false question that asks stem and leaf plots are best used with small data sets, which is true. Okay, stem and leaf plots are best for a small data set. I thought maybe it was on this list, but it apparently is not. Are you okay, Nana?
Yes.
Okay, other questions related to the midterm, either from this document that I just kind of talked about or from the actual review sheet.
Can you go over the exponential distribution on the review sheet?
Okay, I have just toggled over to the review sheet. Let me go down to the exponential problems. Okay, so the exponential distribution problems on the review sheet are questions 65 and 66. All right, so question 65 says, the number of minutes between customers who enter a certain shop can be modeled by the exponential distribution. I'm going to make this bigger where you guys can see it. Suppose a new customer enters a shop every 2 minutes on average. After a customer arrives, find the probability that a new customer arrives in less than a minute. Okay, first off, one of the things you're going to have to be able to do on the midterm is identify the fact that this is an exponential distribution. Well, the way this particular question is worded, it clearly tells you in the problem that the number of minutes between customers can be modeled using an exponential distribution. So ideally, that leaves no doubt in your mind that it's an exponential distribution. It also will benefit you if you have the formulas related to, or the information related to the exponential distribution from the handout that I'm going to give you, or that I'll post. Okay, because we need the decay parameter, we need the mean and the standard deviation, and then it also gives us the formulas for calculating what we need, whether you have area to the left or area to the right. Okay, so I need to think about the mean of the distribution. Well, it says in the story, a customer enters the shop every 2 minutes on average. So the mean is 2. It will also be true that the standard deviation will be 2. Because for the exponential distribution, the mean is equal to the standard deviation. Now, I'll tell you that on that note sheet that I'll be posting. The other important piece is the decay parameter. The decay parameter is represented by the letter M and is equal to 1 over the mean. So for this problem, my decay parameter is going to be 1 over 2, which is 1/2 as a decimal is 0.5. Using the decimal probably will be easier. So then it says, after a customer arrives, find the probability that a new customer arrives less than 1 minute. So an exponential, remember, is kind of this L-shaped curve. Our mean is at 2. And the question asks us less than 1. So 1 would be here, and we want to be less than that. So we're looking for this red, well, it's not red, it's yellow, this yellow shaded region. Well, notice it's less than 1, and less than is to the left. So this, I'm looking for the area to the left because it's less than. And it's important you have to figure that out, because then that identifies for you which formula to use. For area to the left, I need this formula, which is 1 minus. So to calculate this, I'm going to use the formula 1 minus E. I think that's right. Let me make sure. I don't have them memorized. E to the negative mx. E to the negative m times x. At that point, once I've identified that that's the formula that I need, it becomes a plug and chug. So I have 1 minus E to the negative m, the decay parameter is 0.5. My x value is 1 because that was the value that they asked me about, less than 1. Now I can do those calculations to a point are simple enough. I can do them in my head. So I would have 1 whole minus E. Okay, so negative 0.5 times 1 is negative 0.5. And then I'm going to get my calculator and I'm going to type that in. Okay. So I have 1 whole minus, I press second LN to get my E, negative 0.5, and enter. And I get a value of 0.39346934003. It doesn't specify it here in this one, but usually on the test it will. And I usually ask you to round to 4 places. So I have a 4 in the 4th place, but the 6 is next door, so it's going to get bumped. So ultimately my answer here is 0.3935. It's about a 39% chance that a new customer arrives in less than a minute. You okay, Allison?
Yes.
Okay, let me do the next one. I'm going to make it a little bit bigger print where we can see it. Okay, question 66 says, the number of days ahead travelers purchase their airline tickets can be modeled by an exponential distribution with the average amount of time equal, to 15 days. Find the probability that a traveler will purchase a ticket more than 10 days in advance. Okay, again, one of the first things that I notice about this problem is it does clearly identify the fact that this is an exponential distribution. So from that, I need to be able to identify my mean. I need to be able to identify the standard deviation. And we need the decay parameter. Okay, it says with the average equal to 15 days. So the mean is 15 and the standard deviation is also 15, because for an exponential distribution, the mean equals the standard deviation. Our decay parameter is 1 over the mean. The mean is 15. So my decay parameter is 1/15. Now let me see if I can convert that to a decimal. Might be better to use it as a fraction because this is approximately 0.0666 repeating. Okay, so it can get tricky using the repeating decimal. So for this one, I might go ahead and use the fraction. And then the question asked me, probability a traveler will purchase a ticket more than 10 days in advance. Okay. So again, with the exponential, it's kind of this L-shaped curve. The mean is 15. We're interested in more than 10 days. Okay, notice that more than is to the right. Okay, so this is going to be the area to the right. And so our formula changes. The probability for area to the right. And again, you should have these formulas handy. The area to the right is e to the negative mx. So it's e to the negative mx. So I would have in this problem e to the negative 1/15 times 10. Okay, so e to the negative 1 times 10 is 10. 15 times 1 is 15. That's e to the negative 2/3. Okay, it simplifies. And then I'm going to enter that into my calculator. So I do second ln parentheses in my exponent, -2 divide 3, and we get 0.513417119. Again, typically I ask you to round to 4 places. So the 4 is in the 4th place. 1 is next door. It doesn't bump it. So we end up with 0.5134. You okay, Allison?
Yeah, I understand it now.
Okay. Again, most of the problems, guys, when you're looking at the binomial, the uniform, and the exponential, I know for the uniform and the exponential, it's going to clearly tell you it's either exponential or it's uniform. The binomial, you may have to figure out for yourself, but remember, with a binomial, it comes down to you have a fixed number of trials. Your probability of success doesn't change from trial to trial. The trials are independent, and each trial has exactly 2 outcomes. I would probably tell you that if it doesn't say uniform or exponential, it's probably going to be the binomial, because that's the only other option you have on the test. Other questions related to the review sheet or any of the content on the midterm?
Can you go over like that chart that had the what's that, at most, at least, I forgot the name.
This chart?
Yes.
Okay, that chart is directly related to the binomial distribution. Remember, this chart tells you how to solve the problem. Okay, let's go over to the review sheet. Can I do that?
Yes, please.
Okay.
Because it says sometimes that I might forget that I'll end up including the X with whatever the number is, and that
Okay, that's why that table is important, because that's going to help you know whether to include it or not, because it very clearly tells you that on the table. So I'm on the review sheet, and the binomial questions are 58 through like 61, 62.
okay.
Okay. So on the test, see if I can copy this. On the test, what you're going to see is you're going to see this question or something like this. It'll say, according to CNBC, 60% of big companies plan to eliminate jobs during 2020. What is the probability that exactly 5 companies from a sample of 20 randomly selected companies will eliminate jobs in 2020? Round your answer to 3 decimal places, and the mini-tab output results are below. Okay, so I give you this table with the question. Okay, what you have to remember is how to calculate. In this case, the question says exactly 5. Okay, so let's say I don't remember how to do exactly. So the key word here is exactly. So I'm going over to the table that you should print off, and I look for that key word. It happens to be this first row. Probability of exactly. And it tells me, read the results directly from Minitab Well, where did it go? See if I can copy it. Maybe it didn't copy. Copy. Okay, there it is. It says read results directly from Minitab for X. So my X was 5. So I'm going to read down till I find X is 5. And I'm going to read the answer next to it. So it's 0.001294. The instructions tell you to round to 3 places. So the 1 is in the 3rd place. 2 is next door. It does not round up. So my answer is 0.001. That's the answer you would want to put on your paper. Okay, going to the next one, but I need to copy this table again. Now, Nana, I can't see your face, so if you're not following me, you'll have to speak up for me, okay? Because I can't see to know if you are following me or not. Right.
Yes, I'm following you.
Okay, so this one says, same scenario, according to CNBC, 60% of big companies plan to eliminate jobs during 2020. What is the probability that at most 9 companies from a sample of 20 randomly selected companies will eliminate jobs in 2020? It says, do not round until you have your final answer. Then round your final answer to 3 decimal places. Okay, so my keyword here is at most. Okay?
Yes.
So I'm going back over to the table, which is what you were asking me about, and I want to find the phrase at most. Okay? So here's at most. Probability of at most X successes. Okay? And it tells me add the results from Minitab for 0, 1, 2, 3, all the way up to X. So in this problem, the question was at most 9. So you're going to add the values for 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In this case, the way this is written, you do include the 9.
Okay.
Okay, so I need from 0 all the way up to 9. So I have to add those values together. You'll have to be extra, extra careful, okay? But you want to add those numbers together.
Okay.
I'm working on it.
Okay, yeah.
I'm just not reading them out loud so I don't make a mistake.
Yeah.
Okay, so once I've added all those values together, I get 0.12752. Now again, it asks me to round that final answer to 3 places. The 7 is in the 3rd place. 5 is next door. So it does round it up. So this becomes 0.128. Now, a couple of things. The instructions tell you to go from 0 all the way to X. So hopefully that helps you to recognize that you need to include the X. Because if you look at the next option here where it says fewer than, notice that
Yeah.
I clearly say, Nana, do not include result for X.
Okay, so
Okay,
it's
and I didn't say that up here on the at most.
okay.
Okay, so just be careful and watch the words.
Okay.
So let me go to the next one. Let me get my results again. Okay, same scenario, and this one says at least 15 companies. Okay, so the phrase here is at least. So if I go over and look at the table and I look for that phrase at least, it tells me to add the results from Minitab for X. Again, it does include the X the way this is written.
I see.
Let me get this pasted in here. Come on. Okay, so we're going to add the values for 15, 16, 17, 18, 19, and 20. You go all the way to the end. And you start at the value that you're given, which is 15. And again, you're going to add those together. And I'm going to do that. It'll take me just a minute.
Okay.
Okay, when I get all those added together, I get 0.125599. Again, I'm asked to round to 3 places. The first 5 is in the 3rd place. There is a 5 next door. It's going to bump it up. So I have 0.126, and that's my answer. Okay, 61 is really kind of a different question. It's the same scenario, but it's asking you to calculate the standard deviation. Okay, so to calculate the standard deviation for a binomial, it's not on the table that we're talking about, but I do give you those formulas here on this sheet. See, this second one here says standard deviation.
Yes, I see it.
So the standard deviation formula for the binomial is the square root of n times p times q. So you may need me to remind you about what those numbers are. Remember, n is your sample size.
And that's 20?
For this problem, that is 20.
Okay.
P is your probability of success. And in this case, they're telling us 60% are going to shut down or eliminate jobs. I'm going to write that as a decimal.
I was
Q,
just thinking that was 60%.
yeah. Q is the probability of failure, and it's always 1 minus P. So if success is 60%, failure would be 40%, which is 0.40. So all of the numbers are either given to you in the problem or you can figure them out. And then it is a simple plug and chug. So I would have the square root of 20 times 0.6 times 0.4. Remember to follow order of operations. So I would do that multiplication under the square root first. So 20 times 0.6 times 0.4 is 4.8. And then I'm going to take the square root of 4.8, which gives me approximately 2.19089023. I've run out of space. It does ask you to round to 2 decimal places. Okay, so the 9 is in the second place, 0 is next door. It does not get bumped up, so it's 2.19.
Okay. And sometimes when I check the answers, I even what's that? Put in the calculator.
Uh-huh.
Um, I put in I do the multiplication first before the square root, and after I get my answer, I also go back to double check to see if it's the same answer. And I did the square root of 20 times 0.60 times 0.40, and I would get the same answer.
Yes, yes, you should.
Yeah, that's what I did.
Yeah. Okay, question 62. It's the same scenario, but again, this question asks you to find the mean. And again, finding the mean is not on the table, but it's a formula that's given here. The formula for the mean is N times P. So the mean is N times P, where again, N is your sample size, which you already told me was 20, and P is your probability of success, which is the 60%. So to find the mean, I'm going to multiply those two numbers together. So we would have 20 times 60%, which I believe is 1.2. 20 times 0.6. Oops, I'm sorry, it's 12. No, I did that wrong. Oh, maybe I didn't. It's 12. So using that table, it really, if you'll be careful and look for the words that are in the problem. And again, I clearly tell you kind of in the table, don't use the result for X. So if you're not supposed to use it, I tell you, don't use it. So hopefully that'll keep you from getting tripped up.
Yes. Okay.
Other
Thank you.
questions? You're welcome. Other questions about the review sheet, about the test itself?
We go over uniform distribution again.
Go over uniform. Okay.
Yeah.
I'll make these bigger so we can see them. All right, uniform distribution. Question 63 says, the average amount of weight gained by a person over the winter months is uniformly distributed from 0 to 30 pounds. Find the probability a person will gain between 10 and 50 pounds. Okay, So this one again clearly identifies the fact that it is a uniform distribution. Visually, when you draw the picture of a uniform distribution, it's going to be a rectangle. And it tells us that we start at 0 and we go to a max of 30 pounds. And so visually what you're going to have, because it tells us it is uniformly distributed, is you're going to have a rectangle. Now to get the probability, remember the probability equals the function, and the function is 1 over b minus a, where a and b are your beginning points and your ending points. So for this problem, I would have 1 over 30 minus 0, which is 1/30. So my p-value is 1/30. It asks me what is the probability that a person gains between 10 and 15 pounds during the winter months. So my probability corresponds to the area of that rectangle. And if you'll remember from geometry, the area of the rectangle is length times width. The width in this scenario corresponds to the probability. So it is 1/30. The length I can figure out because I'm going from 10 to 15. So 15 minus 10 is 5. So my length is 5. So I have 5 times 1 is 5. 1 times 30 is 30. So it's 5/30 or 1/6. And 1/6 as a decimal would be 0.166 repeating. So we're going to round to 7. Again, it doesn't indicate what to round to. Typically, it's going to be for probability, we do 4 places. Question 64 says the total duration of baseball games in the Major League in the 2011 season is uniformly distributed between 447 hours and 521 hours inclusive. Find the mean and the standard deviation, and then it's got some probability problems. Okay, so if we go back and look on our note sheet under uniform distribution, I have given you the formulas for, see, here's uniform distribution, and underneath it you have the formula for the mean, and you have the formula for the standard deviation. So the mean formula for the uniform distribution is A plus B divided by 2. And you, again, you may be wondering, okay, well, what's A and what's B? Well, that's your beginning point and your ending point. So for the mean, I would have 447 plus 521, all divided by 2. So I have 447 plus 521 is 968 divided by 2 gives me a mean value of 484 hours. The formula for the standard deviation is the square root of b minus a squared divided by 12, I think. Let me double check. Yep, I was right. Again, it's a plug and chug. Okay, so I'm going to take the numbers, plug them in. So I have the square root of 521 minus 447, and that's going to be squared divided by 12. So I have 521 minus 447, which is 74, divided by 12. I then am going to square the 74 following order of operations. That gives me 5,476 divided by 12. So that gives me the square root of 456.3 repeating. And I'm going to take the square root. And I get 21.361959996. So there's the mean and the standard deviation for that problem. It says, what is the probability that the duration of games for the team is between 480 and 500 hours? So again, we have a uniform distribution. My low value was 447. My high value was 580, 521. 521. It is a uniform distribution, which means visually it is a rectangle. To find the corresponding probability, the probability is going to be 1 over 521 minus 447, which is 1 over 74. I'm just going to leave it as a fraction for now. And we want to know what's the probability that it's between 480 and 500. So again, you got to try to find the probability. The probability corresponds to the area under the curve, or this red looking rectangle. So remember, the area of a rectangle is length times width. The width corresponds to the probability, which is 1/74. I can determine my length. It's 500 minus 480, which is 20. So my length is 20. So I have 20 divided by 74. That would be, let's see, if I divide by 4, nope. divided by 2. We're going to get 10 over 37 as a decimal. That is 0.270270270. So if we round it to 3 places, it's going to be approximately 0.270. Now the last one here is a little bit different. This is kind of that cutoff score question that you were talking about. You asked me about earlier, Nana, but this one is related to a uniform distribution. So again, we still have our uniform distribution from 447 to 521 hours. It's uniform, so it looks like a rectangle. We've determined from the previous problem that the probability is 1/74. This one says, what is the 65th percentile? Remember, percentile is always the percentage below the score. So 65%. I know that this kind of purple magenta shaded region is 65%.
You said this one's related to the cutoff question I mentioned?
Well, this is a cutoff question, but it's a cutoff question for the uniform distribution, not the normal.
Oh, okay.
Okay, so I know that that shaded magenta purpley looking region is 65%. I'm looking for what X value does that correspond to. So again, we have a rectangle. We still use our formula area equals length times width. Okay, so I know that my area is 0.65. I know that the width corresponds to the probability, which is 1/74. The length, this is probably the part that gets tricky for students. I'm looking for this X. So I have X, my length would be X minus the 447. I would subtract those two numbers to get the length, but I don't know what X is. So I have X minus 447. And then I have an algebra problem. So to solve my algebra problem, I'm going to multiply both sides of the problem by 74. So I have 74 times 0.65. That's 48.1 equals 74 times 1/74 zeros out, X minus 447. Then I'm going to add 447 to either side. So 447 plus 48.1 is 495.1. So 65% of the time, the ball games lasted roughly 495.1 hours. Guys, a lot of it is knowing the formula and knowing which formula to use when. Questions? Other questions on the review sheet? questions about your project 2?
Can we do a confidence interval?
Okay, the confidence intervals on your review sheet are the last 2 questions, questions 67 and 68.
Okay,
Okay,
yes.
so question 67 says, suppose that pizza delivery times are normally distributed with a population standard deviation of 6 minutes. A random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. Construct a 90% confidence interval for the population mean delivery time. Okay, the first thing that jumps out at me in this scenario is that it tells me the population standard deviation. The fact that I know the population standard deviation tells me that I'm going to do Z. Now, I walk you through a series of questions, and it says, what is the sample mean? Well, if you read carefully in the problem, it says a sample mean delivery time of 36 minutes. So my sample mean is 36 minutes.
Okay,
It says, what is the sample size? It says a random sample of 28 pizza delivery restaurants. So my sample size is 28. The
okay,
population standard deviation, I already identified it's 6. The confidence level we need to create is 90%. From
yes.
that, I need the upper bound, the lower bound, calculate the early bound margin, and write the conclusion. To calculate or construct that confidence interval, we have to go out to Minitab. And I got to get mine opened up. I haven't opened it up this morning. Okay, so we go to Stat, Basic Statistics, 1 sample Z. We know we're using Z because we know the population standard deviation. I have summarized data. My sample size was 28. The sample mean was 36. The known population standard deviation was 6. It's a 90% confidence level. Did it before I wanted it to. It's a 90% confidence interval, so make sure you change that.
Yes.
And it always defaults to not equal, which is what we need. Then I click OK. OK. And I get this printout. On that printout, I have my lower bound. Remember, my confidence interval is out here at the end. The first number in the interval, the lower bound, is the first number, which is 34.13. The upper bound is the second number. It's 37.87.
And that's when the formula comes in to
And
get
then you are correct. You need the error bound for the mean. Which is the upper bound minus the lower bound divided by 2. So I would have 37.87 minus 34.13 all divided by 2. Do the subtraction in the numerator first. 37.87 minus 34.13 gives me 3.74. And 3.74 divided by 2 is 1.87. And lastly, you write your final conclusion. Remember, the wording of this conclusion is important. We say, we estimate with 90% confidence that the true population mean, see, what are we talking about? Mean delivery times is between 34.13 minutes and 37.87 minutes.
Okay.
Now, remember, Nana, on this one, you had the population standard deviation. When you know the population standard deviation, you do Z. But if you do not know the population standard deviation, if you look at the second one, you don't know the population standard deviation. Excuse me, so you use T. But the process is the same.
Because you need a sample standard deviation.
If you only have the sample standard deviation, you're going to do T.
Okay.
Other questions?
I don't think I have any more.
Okay. Emmanuel, Keyshawn, Gabriella, anybody have other questions? Emmanuel, I can't hear you if you're speaking. I saw you unmute.
I think that was it for me.
Okay. Okay, here's the deal, guys. Quiz. Let me make sure what quiz number it is, because I don't remember. Oh, wrong one. Quiz 6. Quiz 6, which covers confidence intervals, is due by Sunday. The midterm exam is now available and it must be taken by Sunday. You need to allow a 2.5-hour window for taking the midterm, but it is now open and you can take it. But you need to allot 2.5 hours. You cannot start, stop, start, stop, start, stop. So you've got quiz 6 due by Sunday, midterm due by Sunday. Mini project 2 is not due till Sunday, April the 9th, which is at the end of spring break. Okay, but you can go ahead and submit it early. It deals with confidence intervals.
Okay.
Any other questions? I will be monitoring email over the next couple of days should you have a question. When you finish your midterm, you will not automatically get your grade because the last 2 questions are short answer where you have to fill in the answers. So I have to go in and physically grade those. But I will try to monitor submissions so that I'm grading them as you submit them and try to get it back to you within 24 hours. Okay? So just be aware of that. You will not automatically see your grade on the midterm till after I grade it and release it.
Okay.
So good luck on the midterm. Make sure you use your resources. And I will see you on Monday, April the 10th. Remember, we do not meet next week because it's spring break. And we will pick up our discussion of Module 3.
Oh, that's my birthday.
So y'all have a good weekend and a nice spring break.
And you say you're gonna send the document to us?
I will. I'll post it up here in just a minute.
Okay.
All righty.
Thank you for the review.
You're very welcome.
Okay. Bye.
Bye.
Have a good day.
You too.